Yeah, good afternoon to one and all. We are going to deal with the magnetization characteristics of a DC shunt generator, that too theoretical calculations wise. This one is a circuit diagram. We already conducted our experiment here. This one maybe call it as line, armature, field, and we have some two rheostats now. One thing is armature rheostat 18 ohms, field rheostat is 360 ohms. We have to keep this armature rheostat is in maximum position. Why means we don't want to start our motor initially with a high current cell. That's why I'd like to keep maximum resistance in order to draw only small amounts of current at the starting time. And we can have some field resistance should be in minimum position. This one is minimum. Armature rheostat is in maximum position. And we already know that in order to make it this entire motor to the rated speed 1500 rpm, I just want to vary this rheostats here in order to keep motor speed at rated, that it is 1500 rpm. Then we can have some mechanically it is rotating like this with a speed of 1500 rpm, and that mechanical energy is coupled to generator. Then this generator will extract some electrical energy, that it is induced EMF. We observed with the help of some voltmeter, and this one is the ammeter for the sake of field current. By varying this field rheostat, we observe that there is some increase in the part of current and voltage. We have to note down these two readings here, and we have to keep this field rheostat is a maximum position. Why means that current is inversely proportional to resistance. If you are having some maximum resistance, there is some small amount of current is there. If I'd like to reduce this rheostat, there is some increase in the current, and we can note down these readings of induced EMF and field current. Yeah. This one is the thing. In order to extract the things of critical resistance, I just want to have this tableau column here right now. Generated EMF, field current. At a field current of 0, we can have some 8 volts is there. Due to the residual magnetism, we have some small amount of voltage is there. The graph doesn't start from origin. It has to be started at 8 volts. And we can plot all this curve here right now. This curve, red colored curve, maybe call it as open circuit characteristics. And in order to obtain critical resistance, I just want to draw one tangent for this curve, open circuit characteristics curve. Then I can identify these 2 points right now. This y-axis term maybe call it as 120 volts, and this x-axis term it's approximately 0.25. That it is V equal to IR now. From that R is equal to V by I. Then I can identify 120 upon 0.25 is equal to 480 ohms is our critical resistance. Then I'd like to go further. In order to go further like this, in order to identify the critical speed, we can have some one more point here. In the laboratory, we observed one field resistance value. It's approximately 280 ohms. From that, it's nothing but it's just a slope there. We all know that y equal to mx now. From that, m equal to y by x. And I would like to identify randomly what's the value of v and what's the value of I. That it is, I'd identify one value here, that it is 70. And I can identify this I value is approximately 0.25. Then I can identify this point and I can draw a straight line like this. These are the 2 points. This point maybe call it as V1 and this point maybe call it as 0.25. And I can also identify one more point. This one is for the rated speed and this one is the critical speed you have to find out. This value may be call it as V2 and this value may be called it as V1. And this speed may be called it as rated speed, red colored line, and this one critical speed. What's the formula here is V2 by V1 is equal to rated speed divided by critical speed. Then this one is formula. I can identify critical speed is equal to 1500 into 70 divided by 120. It's approximately 875 rpm is the critical speed. We also obtained this graph with the help of only these specific readings. Apart from the readings, I would like to draw this line with the help of this field resistance. It's approximately 280 ohms. With the help of that slope formula, we identify this point. We extrapolate this V1 and V2, and we can have this critical speed here right now. Yeah. Thank you. Thank you for